Hello my dear students, welcome to IMS GATE Academy. As we are inching towards the GATE exam, a formula sheet will help you to quickly revise the formulas. My dear students, I am here to discuss the quick formula sheet on RCC, that is reinforced cement concrete, and it has a weightage of 4 marks in the GATE exam. So my dear students, this 1 hour the agenda is how quickly you can revise all the formulas in the RCC. Before starting the session, I would like to tell you the key silent features of IMS GATE Academy. We at IMS GATE Academy provide 800 plus hours of GATE coaching. It includes offline GATE coaching as well as we provide online GATE coaching, and also we provide the self-recorded sessions. We at IMS GATE Academy, the silent features of IMS GATE Academy are we provide subject-wise material and we provide the exercise books which contains level 1, level 2, level 3 questions, which includes MCQs, NAT and MSQs. And my dear students, let me tell you, if you are looking for a test to practice, then you have to definitely visit the website of IMS GATE Academy, where we provide chapter test, subject test, advanced level test, multiple subject tests, and also my dear students, we are providing the basic All India mock test series, which will be the replica of the GATE environment exam. And my dear students, the key success for IMS GATE Academy on the basis of the student ranks, we achieved the good ranks and we have got student success through one-to-one mentorship, and also we have doubt solving portal. So let us quickly start the topic RCC. My dear students, when I start reinforced cement concrete, what do you mean by RCC is reinforce. Reinforce is make it stronger, and cement and concrete are used in steel and concrete are used in RCC. The agenda is simple, sir. The coefficient of thermal expansion of both the materials is almost same. That is the reason, my dear students, in RCC they are using the steel and concrete. Now coming to the first method, we have the limit state method. My dear students, when I talk about limit state method, it is a superior method. Why it is a superior method is, it is designed for higher loads. It is designed for higher loads and we are allowing the lesser strength. We are having higher loads and lesser strength. By these two factors, we are ensuring double safety. So my dear students, there can be an interview question in any of the corporate interview questions when you are attending the structural engineering jobs. So why do we use steel and concrete? The coefficient of thermal expansion of steel and concrete is almost same. That is the reason we use steel and concrete in RCC. Why LSM method is appreciated or superior? It is designed for higher loads and lesser strength. That is the reason it ensures double safety, which is very important for a design engineer. Now my dear students, when I talk about RCC, there are two terms which you have to learn. What is the basic difference between design and analysis? Design means finding dimensions and analysis is finding the load calculations, bending moment, shear force, all these comes under analysis. I hope you are clear with the basic agenda. What is the difference between analysis and design, and why LSM method, and why do we use steel and concrete? So let us quickly go into the IS 456 code according to the LSM method. Now my dear students, whatever I am discussing in this slide will help you a lot. Suppose my dear students, we have one section, a beam which is reinforced on tension side is known as singly reinforced section, and the strain is going to vary linearly in this section. Here the maximum strain in concrete is 0.0035 and the maximum strain in steel is 0.87 Fy by Es plus 0.02. The maximum strain in steel depends only on the grade of the steel, my dear students. Now if I talk about the stress distribution, the stress distribution varies rectangular parabolic, and here the stress at top is given as 0.446 FCK, or you can write it as 0.45 FCK, and the compression force is supposed to act at a top distance 0.42. You can say it as act at 0.42 XU, where XU is the depth of neutral axis. Okay, that here the compression force, here what is 0.4 to XU is the distance from top, you can write it as 0.4 to XU, and the compression force is 0.36 FCK B into XU. Similarly, my dear students, the tension force is 0.87 FIAST, and the strain at this parabolic juncture, it is 0.002. So let us understand these terms very clearly. Now here see students, let me tell you what do you mean by compression force. The area of the stress block diagram is nothing but the compression force, and here compression force is given by the formula. Compression force is equal to, what is the formula, sir? You can write it as 0.36 FCK into B into XU. This is nothing but the compression force. Okay. Now my dear students, when I talk about tension force is given by the formula is equal to 0.87 FIAST. Okay, my dear students, why do you want to learn these two things is to find the depth of neutral axis, we assume the section to be balanced. So for finding the depth of neutral axis, we assume compression force is equal to balanced, compression force is equal to tension force, which says that the section is balanced. So here you can write compression force is equal to tension force, and you can write here XU is equal to 0.87 FI AST upon 0.36 FCKB. Very, very important formula, my dear students. Okay. Now see students, if I talk about the lever arm distance, the lever arm distance can be taken as D minus 0.42 XU. Okay. Now if they ask you what is moment, moment can be written as, because in balanced section compression force is equal to tension force, you can write moment can be written as compression force into lever arm, or you can write that tension force into lever arm. I hope you are clear, and these are very, very important equations. So how do you calculate compression force? 0.36 FCK BXU. How do you calculate tension force? 0.87 FIAST. Depth of neutral axis is formed using by assuming the section as balanced. Lever arm is D minus 0.42 XU. Moment is equal to compression force into lever arm. Now my dear students, let me tell you, when do you say the section is balanced, when do you say that the section is under reinforced, and when do you say the section is over reinforced? So first I will write like a table kind of thing. We will consider balanced section, and we will consider under reinforced section, and I told you my dear students, practically all the sections are designed as under reinforced, and we have the other section as over reinforced. Now this table will help you to understand the conditions for each section. My dear students, when I talk about the balanced section, we know that XU is equal to XU max and AST is equal to AST limiting. These are the conditions to learn, my dear students. Limiting area of steel. So when XU is equal to XU max, you write AST is equal to limiting area of steel. And the balance section failed primarily by primary compression. It failed mainly by what, sir? Primary compression. Now my dear students, if I talk about the under reinforced section, here XU is less than XU max. Here XU is less than XU max. Okay. And if you talk about the AST is limiting, AST is less than AST limiting. And here the failure is in steel, sir. As steel is a ductile material, it shows a clear sign of failure. And here the primary failure is by primary tension. Here is the failure is by primary tension. Okay. Now how do you solve the problem for over reinforced? Here remember students, if the failure is in concrete, that we cannot apply that thing in practically, because concrete is a brittle material. The failure will be sudden. It will not show any sign of failure, sorry. So when I talk about the over reinforced section, XU is greater than XU max. So we have to practically avoid this section. AST greater than AST limiting, and here the primary failure is by primary compression. So these 3 points you should be aware whenever you are talking about reinforced, under reinforced section, over reinforced section, or if you talk about the balanced section. So these are the conditions. When do you say that it is under reinforced or over reinforced or balanced section? Now my dear students, let us go. Suppose if you take FE 250 grade, okay, when you take about FE 415 grade, and similarly if I take a FE 500 grade, okay, we have different grades of steel. Now in this we have XU max by D values. What, sir? XU max by D values will be equal to, for FE 250 it will be 0.53, for FE 415 0.48, and FE 500 it is 0.46. Similarly, my dear students, when I talk about limiting moment, sir, what do you mean by limiting moment is nothing but when XU is replaced by XU max in the moment equation, we call that moment as limiting moment, and here you will be getting 0.149 FCK BD square and 0.138 FCK BD square, and for FE 500 0.133 FCK BD square. Now the important observation you should know, when the grade of the steel is increasing, the moment, limiting moment is decreasing. That is one of the important thing you have to observe. And remember my dear students, XU max by D value depends only on grade of the steel. This was one time grade question, sir. XU max by D value depends only on grade of steel. So that is the reason if you see, I have told different grades of steel and I have given you different values. So when the grade of the steel is varying, the XU max by D as well as the limiting moment of resistance will vary. I hope you are clear. So let us understand what is the maximum. I told you already, students. See, in the 2023, they have given one question, sir. What is the maximum strain in steel? Remember, my dear students, the maximum strain in steel is given as the formula 0.87 Fy by Es plus 0.02. This is the formula for maximum strain in steel. Similarly, if they ask you maximum strain in concrete, you can write it as 0.0035. So my dear students, I might be fast because I don't want to waste your last minute preparations. So that is the reason I am just quickly revising the formulas. Okay, next, if I talk about the partial safety factor, my dear students, if I talk about the partial safety factor for concrete, here see students, when I talk about the partial safety factor for concrete, it is 1.5 in LSM method, and if you talk about steel, it is the partial safety factor for steel is 1.15. Now immediately you can ask me why the partial safety factor for concrete is more when compared to steel. You can say the reason is quality control. That means concrete is manufactured where, my dear students? Concrete is manufactured in the field, whereas steel is manufactured in the industry. So we have less probability of failure for steel, whereas concrete is made in the field. There are high chances of failure. That is the reason we are taking the factor of safety more, or simple words you can say quality control is the reason. Okay. Now let us go into the next point, my dear students. Suppose what is the stress strain curve for concrete? If you see the stress strain curve for concrete, the stress strain curve for concrete is given as rectangular parabolic. It will be in this way. You can say here it is 0.002. Okay. It is 0.0035, which I have explained you. So here the stress strain for concrete is, you can write rectangular parabolic. But remember, my dear students, it need not be rectangular parabolic. Here whatever this zone you have, this whatever I am showing in the shaded zone, this can be any shape. But there is a clause that in the code, if the test results are satisfied. If you consider here about the steel graph will be somewhere like this. Now, okay students, so anyhow the y-axis represents the stress, independent quantity will be on the x-axis, that is strain. So, my dear students, if you talk about the strain in steel, if you talk about the design strength in steel, you told yield strength by partial safety factor of steel. The partial safety factor for steel is how much? It is nothing but 1.15. If you divide this, you will get a value of 0.87 Fy. Because some of the students might have doubt how we got 0.87 Fy. This is how we have calculated. So I hope you are clear with this basic compression force. Let me quickly revise this. Compression force is 0.36 FCK BXU. Tension force is 0.87 Fy AST. And lever arm is D minus 0.42 XU. For FE 250, FE 415, FE 500, XU max by D value is 0.53, 0.48 and 0.46. Similarly, limiting moment is 0.149 FCK BD square, 0.138 FCK BD square, 0.133 FCK BD square. Now see students, let me tell you the minimum tension reinforcement. This was also asked in one time gate exam, sir. The minimum tension reinforcement is AST by BD is equal to 0.85 by Fy. AST by BD can be written as what, sir? 0.85 by Fy, where Fy is the yield strength. Okay. Similarly, my dear students, if they ask you what is the maximum tension reinforcement, if they ask you what is the maximum tension reinforcement is written as 4% of gross area, which is very important, sir. It is taken as 4% of gross area, or you can write it as 0.04 B into capital D. Sir, most people are habituated to write small d. If you write small d, it will not be gross area. That is the reason I used the word gross area. I hope you are clear. Now, similarly, my dear students, if I talk about effective span, sir, if I talk about the effective span, how do you calculate effective span for simply supported beam? If I take, it is taken as what, my dear students? It is taken as center to center distance, first option. Second one is clear span plus D. Clear span plus D, and whichever value you get less, that will be taken as effective span for simply supported beam. My dear students, if I talk about cantilever, it is taken as clear span plus, D by 2 for cantilever. I hope you are clear. If it is for simply supported beam, it is clear span plus D. If it is for cantilever beam, it is clear span plus D by 2. So for maximum tension reinforcement, it is 4% of gross area. Minimum tension reinforcement is AST by BD is equal to 0.85 upon Fy. I hope you are clear with this. Now, my dear students, when I talk about the basic things like shear, if I talk about shear, sir, these are very, very important. Now, see students, in shear, you have to follow the basic steps. Suppose here we will calculate tau V. What do you mean by tau V? Tau V is nothing but what, sir? Nominal shear stress. What do you mean by tau V? Tau V is nothing but the nominal shear stress. And here, my dear students, tau V can be calculated as Vu upon Bd. What is Vu? Vu is nothing but the shear force. Bd is the section, okay, section dimensions. Now, here the second step is, if tau V is less than 0.5 tau C, you required no shear reinforcement. What, sir? If tau V is less than tau C, no shear reinforcement is required. Now, my dear students, if tau V is less than tau C, you should provide minimum shear reinforcement. What, sir? If tau V is less than tau C, what you have to provide? You have to provide the minimum shear reinforcement. What is the minimum shear reinforcement is? You can write ASV upon B into SV is equal to 0.4 upon 0.87 EFY. So, this is the formula for minimum shear reinforcement. Now, my dear students, when tau V is greater than tau C, you should say shear reinforcement is mandatory. What, sir? When tau V is greater than tau C, shear reinforcement is mandatory. Now, let me tell you one important thing, students. Here, the design shear force can be calculated as tau V minus tau C into B into D, or another design shear force is 0.87 Fy into ASV upon D into SV. Okay. how this formula came d by SV is, see students, usually if I consider the stirrups like this, okay, usually the length of the crack, if you take, it will be equal to d, sir. Okay, and the spacing between the stirrups will be SV. So the number of stirrups will be taken as d upon SV. So that is the reason here d upon SV came. So let me explain you the shear concept. When tau v is less than 0.5 tau c, you should not require any reinforcement. When tau v is less than tau c, minimum shear reinforcement is required. ASV upon BSV is equal to 0.4 upon 0.87 Fy. When tau v is greater than tau c, shear reinforcement is mandatory. And you have to say that design shear force is equal to tau v minus tau c into BD and 0.87 Fy into ASV into d upon SV. So this is all. Now my dear students, actually due to shear sir, there can be two failures, my dear students. What are the two types of failures is, one is the diagonal tension failure, and other one is diagonal compression failure. What is the other failure we have? Another one is the diagonal compression failure. Now my dear students, our agenda as a structural engineer is, we have to overcome this, because we should not allow the structure to fail in tension or compression. So what is the, how do you take care of diagonal tension reinforcement is, you will provide the steel, sir. What you will do, my dear students, you will be providing the steel. Okay, how do you provide the steel is, this is called secondary reinforcement, because the whatever the main steel, apart from the main steel we provide that we call it as secondary reinforcement. This steel can be provided in the form of bent up bars or inclined stirrups or stirrups. This we call it as secondary reinforcement. Now my dear students, diagonal compression failure, we should not allow this thing to happen. So there was a previous gate question, how do you check this? Suppose if tau v is greater than tau c max, we have to redesign. Why we have to redesign? We should not allow the diagonal compression failure. So they can ask you, what is the check for diagonal compression failure? Tau v greater than tau c max is a check for diagonal compression failure. And let me tell you, my dear students, tau c max is a function of grade of concrete only. What, sir? It depends on the grade of concrete. So that is one of the reasons we are taking tau c max. And here tau c max will be calculated as using the formula 0.62 root FCK. So my dear students, how do you take care of diagonal compression failure is, you will not allow that failure to happen by checking tau v greater than tau c max. By checking this condition, you will avoid the diagonal compression failure. And my dear students, tau c, which is the permissible shear stress, this tau c depends upon FCK, that is grade of concrete, and also it depends upon percentage of steel. So these are the two conditions on which the tau c value will depend. I hope you are clear with the shear concept. Now see students, suppose if there is any torsion, sir, if there is any torsion coming into picture, sir, what do you mean by torsion? Means in canopy beams, there is something like twisting, or if you have radial distances, like if you see these, we call it as grid beams, these. Okay, in this case you will find a torsion kind of thing. So you have to take care of the torsion so that you can design safely. So how to avoid this torsion is, you will take care in case of shear. So here, my dear students, when you talk about the torsion, we come across a concept called equivalent shear. What, sir? We will come across a concept called equivalent shear. So how do you calculate equivalent shear is, equivalent shear can be calculated as VU plus 1.6 TU upon B. What, sir? How do you calculate equivalent shear is, it is calculated by the formula shear force plus 1.6 TU by B. What is this TU means? This is nothing but the torsional moment. Okay, similarly, equivalent moment, we will take moment plus moment due to torsion. How do you calculate the moment due to torsion is, moment due to torsion is given by the formula TU into 1 plus D by B upon 1.7. Most of the people might write this wrong, sir. Here also I am telling capital D. Capital D means overall depth you have to consider. That is another important thing. So my dear students, whenever there is secondary reinforcement, it not only takes care about shear. If there is a torsion, we will increase the shear design, that is equivalent shear, and we will increase the equivalent moment, and we will take care in case of the secondary, like in case of the secondary reinforcement. Very good. Now see students, when I call about the design of T-beams, when I talk about design of T-beams or L-beams, we call design of T-beam. If I tell you, see students, when I talk about design of T-beams, what do you mean by design of T-beams? T-beam or L-beam usually used in continuous T-beams, means in slabs we will be using these T-beams, and L-beams. These are called what, sir? Flange beams. Design of T-beams or anything we call it as what, sir? Flange beams. Now my dear students, let me explain you the design. Suppose if we take a section here, suppose if I have considered a T-beam here, if I consider here a T-beam, suppose here we consider this as depth of neutral axis. But see students, if suppose the neutral axis lies here, okay, in the first case I am telling you, we will talk about case by case, sir. Case 1. Case 1 is, if you say the XU, this we call it as depth of the flange, we take this as XU, which is called depth of neutral axis. In case 1, my dear students, when XU is less than depth of the flange, we design the T-beam, sir, these are very important, Amma. We design T-beam as a rectangular beam. We design T-beam as what, sir? We design the T-beam as a rectangular beam. Okay. Now what I would like to tell you here, see students, when XU is less than DF, we design the T-beam as rectangular beam. But you will have one condition, sir. We know 0.36 FCK B into XU is equal to 0.87 FY AST. Sir, when you are a student who are preparing for GATE, you should have asked me this question, sir. Whether B will be the breadth of the web or flange. Now see students, we take this as breadth of the flange and we take this as breadth of the web. Now the design might be costly and it is a dangerous side to have the neutral axis at the flange. So here my dear students, whatever B is there, it will be replaced by breadth of the flange. You will take B is replaced by breadth of the flange in case the neutral axis lies in the flange. So this is the important note how to solve a T-beam. Now my dear students, in T-beam also if they ask you strain, the strain varies same linearly only, sir. You can say at steel, because there was a GATE 2023 question, here also 0.0035 upon 0.87 by Fy by Es plus 0.002. Okay, the same concept you can apply. Now my dear students, if I ask you one question, sir. If suppose we have a T-beam here, suppose if we have a T-beam here, okay my dear students, if suppose the neutral axis lies in web, so you can say here, the stress will be like this. One thing is, see student, this we call it as 3 by 7 XU and we have here 4 by 7 XU. Now my dear students, if XU, are you following my dear students? Any questions, feel free to ask in the chat box. Sir, we at IMS GATE Academy are dedicated, and my dear students, we follow a systematic approach at the IMS GATE Academy YouTube channel. If you are really interested for the latest updates, how to prepare for the GATE exam, what should be the strategy, what should be the roadmap for GATE 25 also, you can just join the Telegram group which is mentioned in the description. And my dear students, if you are looking for the offline or online GATE coaching, offline we are providing at Jayanagar and also at Andhra Pradesh we are providing at Vijayawada near Bench Circle. So my dear students, if you have any queries related to the subject preparation or what should be the strategy, or are you looking for the post-GATE guidance after the scoring a better score in GATE exam, then IMS GATE Academy is the YouTube channel where you get all the updates. So please join the Telegram group and get all the updates. In addition to this, see students, if XU is greater than DF, what sir? Here when XU is greater than DF, this indicates that what sir? Neutral axis lies in, when XU is greater than DF, you should understand that neutral axis lies in flange. Okay. Now see students, suppose here one condition is there. If 3 by 7 XU is greater than DF, if 3 by 7 XU greater than DF, what is this 3 by 7 XU? You might be studying like 0.42 XU. Okay, why 0.42 XU greater than DF? Or some people might have studied in this. Sir, see, the logic is simple. If 3 by 7 XU is greater than DF, this indicates that stress is uniform throughout the flange. What does this statement says is, stress is uniform throughout the flange. So when the stress is uniform throughout the flange, you can analyze the T-beam using simple technique. Let us solve how it will be done. So here if I talk about the T-beam, see students, if I talk about the T-beam can be habituated like this. So this is the flange, and if we have, this is the web. Okay sir, this is the web. Now my dear students, if you talk about the flange, suppose if you talk about the compression force can be taken as the stress at top is 0.45 FCK. Okay, this is the stress into breadth of the flange minus breadth of the web. Okay, into depth of the flange plus, this is nothing but a rectangular section. So you can take 0.36 FCK BW into XU. Okay, this is how you calculate the compression force. Now my dear students, if I talk about the moment in this case, here if you talk about the moment, just you have to take this is force, no, 0.45 FCK into breadth of the flange minus breadth of the web into DF into, here the lever arm will be D minus DF by 2, because the centroid will act at the center of the depth. For a rectangular section, anyhow you know 0.36 FCK, because it is same as a rectangle BWXU into D minus 0.42 XU. So I hope you are clear how to calculate the moment and compression force and for the T-beam. Now my dear students, if I take here, suppose if I take a section here, okay, we have the T-beam here. Okay, now if I consider the section like this, if the neutral, here also same condition. Sir, see students, when XU is greater than DF, neutral axis lies in what, sir? You can say that directly, neutral axis lies in web. But my dear students, let me tell you one important thing, sir. If this value is how much, students? This value is 3 by 7 XU. And what is this value, sir? This value is 4 by 7 XU. Suppose, my dear students, let me tell you one important thing. If 3 by 7 XU is less than DF, then the stress is not uniform. What, sir? Then the stress is not uniform. What does the code says is, code has given you one important thing, sir. What does the code says? Code says a point called YF. They have come up with a concept called 0.15 XU plus 0.6 DF. Sir, code has come up with a factor called YF. Wherever you find DF in the previous case, replace the DF with YF, you can solve this problem. So in case 2, replace DF with YF and apply the same formulas. Okay sir, case 2, replace case 2 formulas with the DF with YF, you can solve the things. So I hope you are clear with the T-beams design also. Now see students, let me tell you another important thing, sir. If I talk about the short-term modulus of elasticity, short-term modulus of elasticity is given by the formula. Previously it was 5700 root FCK, students. Now if I talk about the short-term modulus of elasticity, it is taken as 5000 root FCK. Okay, this is known as the short-term modulus of elasticity. And similarly, if I talk about the long-term modulus of elasticity, if I talk about long-term modulus of elasticity, long-term modulus of elasticity is given by the formula short-term modulus of elasticity upon theta. What is theta here? Theta is nothing but the creep coefficient, or you can write it as ultimate creep upon, elastic creep. What, sir? You can write it as ultimate creep upon theta can be written as ultimate creep upon elastic creep. I hope you are clear with this short-term modulus of elasticity and long-term modulus of elasticity. Now, if they ask you, my dear students, what is the flexural strength of concrete? The flexural strength of concrete is given by the formula 0.7 root FCK. Okay, sir, the flexural strength of concrete. Sir, sometimes they might give you some problems like this. P upon stress, they can ask you load upon area. Here area you should be very careful, amma. There will be some surface area into length. Okay, the pi d represents the surface area, L represents, because if they take a cylinder or something. Okay, now in a particular problem it will come. That is the reason I told you. Now, my dear students, if I talk about the flexural strength, we are done. Now, see students, we have an important concept called characteristic strength. What, sir? We have a characteristic strength. Sir, see, in characteristic strength, you can say it is the strength at which 95% of the test results are expected to pass, or it is the strength at which not more than 5% of the test results are expected to fail. When I talk about characteristic strength of concrete, you can say 95% of the test results are expected to pass, okay, or not more than 5% of the test results are expected to fail. Now, there is another important thing, students, I would like to tell you. Suppose if you have taken 3 concrete cubes, individual variation in the strength of the cubes cannot be more than plus or minus 5%. What, sir? Individual variation in the strength of the concrete cubes cannot be more than plus or minus 15%. Suppose, see students, how it will happen. If you take 3 cubes, 1 plus 2 plus 3, and if you are designing for 30, you cannot take one 22, other 30, and other one you cannot take 30 because 38. This set will be wrong. Why? Because the individual variation is more than 15%. Suppose if you take 28 plus 30 plus 32, that design might be true. So that's what I would like to tell you in case of the design of M30 concrete. I have given that individual variation should not be more than plus or less than plus or minus 15%. Now see students, if I talk about the frequency, frequency means number of cubes. You can write number of cubes on x-axis, y-axis, and here if I talk about the strength, sir, how the 95 probability curve? See students, if you see the probability curve, it will be somewhere like this. So here if I talk about the 5 percentile, more than 5 percentile, the test results are expected to pass. If you see, this is called standard deviation. We call this as standard deviation. Now, my dear students, there was a previous gate question also. If the characteristic strength is defined as the strength at which not more than 50% of the test results are expected to pass, then target mean strength and characteristic strength will be same. You can write here, target mean strength can be written as FCK plus K into S, okay, where K is a constant, you can take it as 1.65 plus 1.65 S. Now, my dear students, how to find out the standard deviation? Standard deviation is given by the formula sigma F individual minus F average, or average mean strength whole square upon n minus 1 whole power square root. This is where you follow for n is less than 30 samples. This is how you do the things, sir. I hope you are clear with the characteristic strength. Now see students, there can be a question asked in development length also. Okay. The development length is given by, actually, see students, how much is the length embedded into the concrete. Suppose if I take this as a concrete and if you have this as a steel rod, how much length it has been embedded. Actually, we will calculate by using the surface area and the tension force. Suppose here we have the tension force, sir. What is tension force? You can write it as 0.87 Fi, okay, tension force into AST, okay. And similarly, what will be the stress here? We will be calculating on the this side, on which is acting on the surface. So if you do this, you know development length can be taken as what, sir? 0.87 Fy into sigma S upon 4 tau BD. Okay. Or if you solve this, you can know, sir. Here bond stress is tau BD amma, and it is acting along the surface of the length pi d into length of the development length is LD. And if you equate this, you can know it is 0.87 Fy into AST can be written as pi by 4 into d square. Okay. Now see students, if I calculate here development length, LD is equal to, you can write it as pi cancel, d capital D cancel. So you can write it as 0.87 Fy into 4 tau BD into dia of the bar. In some books you might have written phi. Phi is nothing but what's a dia of bar. So how do you calculate the development length? I hope you are clear. Okay, sir. Now, sir, see, when I talk about footing column, sir, see, in column we have two things, sir. One is a short column and other one is a long column. The columns are of two types. One is a short column and other one is a long column. And when do you say that a column is short column and when do you say that a column is long column? See here, my dear students, if the effective length by least lateral dimension is between 3 to 12, we can call it as short column. Sir, if it is less than 3, then we call it as pedestal. Are you following, my dear students? I might be bit fast, sir, but the end of the agenda is how quickly we have to revise the things. Sir, the long column is effective length by least lateral dimension. If it is greater than 12, greater than or equal to 12, we call it as long column. Short column will fail by crushing, long column will fail by buckling. Now, my dear students, how do you calculate the ultimate load? Sir, ultimate load is given by the formula 0.45 FCK into AC, area of concrete, plus 0.67 Fy, area of steel in compression. Are you getting, my dear students? This is one of the important formula where we have to study. Now, my dear students, for every column, we design the column is having minimum eccentricity. So, if you calculate the minimum eccentricity, you know unsupported length upon the minimum eccentricity is calculated by unsupported length by unsupported length by 500 plus least lateral dimension upon 30. Least lateral dimension upon 30. Okay, sir? Sir, I have written a spelling. Okay, because I don't have the space. Here you can write minimum eccentricity. Now, for any column, we design the column as for minimum eccentricity. And this is the problem. Sir, in GATE 21 or 2018, we have, if the column is designed for eccentricity of 0, then the ultimate load formula you should be aware, 0.45 FCK into area of concrete plus 0.75 Fy ASC. Now, my dear students, it's my sincere request you please remember both these formulas because these are the questions they can ask you in the problems, sir, related to column. Okay, now my dear students, let me quickly explain you the losses of pre-stress. What are the losses of pre-stress is? Sir, we have different losses, my dear students. If you talk about elastic shortening of concrete, the losses which are specific to both pre-tensioning and post-tensioning I will be discussing. First, my dear students, when I talk about elastic shortening of concrete is given by the formula M into Fc. What is M, sir? M is nothing but the modular ratio. Fc is nothing but the stress at the level of steel. M can be written as Young's modulus of steel upon Young's modulus of concrete, and Fc can be written as load by area, stress at the level of steel. That is a very, very important point, student. P square by, because most of the people take the value at the extreme fiber, which will be wrong, sir. And see, when all the wires are tensioned at a time in post tension, there is no loss due to elastic shortening. Now, see students, loss due to creep of concrete. Loss due to creep of concrete. Loss due to creep of concrete is given by the formula phi into M into Fc, where phi is nothing but the creep coefficient, which is known as ultimate creep by elastic creep. Sir, actually the loss due to creep is like elastic shortening means when the wires are compressed, okay, there might be a shortening of concrete takes place. Or sorry, if you do the tensioning operation, the concrete will expand, the steel will expand and the concrete might shorten. If you talk about creep, it is a long-term deflection, sir. It will not happen immediately. By the word itself, creep means it is a long-term deflection. Now, my dear students, if I talk about the loss due to creep of shrinkage, loss due to shrinkage is given by the formula. It is given by the formula shrinkage strain into Young's modulus. Sir, shrinkage strain for pre-tensioning it is 3 into 10 power minus 4. For post-tensioning it is equal to 2 into 10 power minus 4 upon log 10 to the T plus 2, where T is the age of concrete in days. And we also have relaxation of stress in steel, sir. What is loss due to relaxation of stress in steel is, sir, the loss due to relaxation of stress in steel will depends upon the manufacture of steel. If the manufacture is done by Tata, the loss will be different. If the manufacturing is done by Jindal Steels, the loss will be different. So it varies from manufacturer to manufacturer. Now, my dear students, there is another important thing. Loss due to friction. Loss of pre-stress due to friction. And remember, my dear students, when I talk about the loss of pre-stress due to friction, this loss is specific to post-tensioning. This loss cannot be occurred even in pre-tension. So the loss of pre-stress due to friction is given by the formula delta P is equal to P naught into mu alpha plus K into X bar. Here, my dear students, what do you mean by mu? Mu is nothing but the coefficient of friction. Alpha is the cumulative angle in radians. K is called the wobbling constant. X bar is the length of the span. Sir, I hope you are clear. If I talk about the cumulative angle in radians, suppose if the parabolic tendon is there. So here theta 1, if there is there, theta 2. Cumulative angle will be taken as theta 1 plus theta 2. So this is the formula for loss of pre-stress due to friction. And this loss is observed only in post-tensioning. Now, next one is loss of pre-stress due to anchorage slip. When I talk about this loss of pre-stress due to anchorage slip, my dear student, this loss is also observed only in post-tensioning. And here it is given by the formula Young's modulus into delta L upon L. Here what is delta L is nothing but slip. What is delta L, sir? Delta L is nothing but the slip. So Young's modulus, ES is the Young's modulus of steel. Delta L by L is the slip and L is the total length. So these are the losses, sir. Now if you do the analysis of pre-stressed concrete, let me give you one basic equation. With this basic equation you can say anything. Suppose the stress at bottom is given by the formula. Sir, if they used the word to avoid tension, then my dear students, the stress at the bottom will be 0. So the stress at bottom can be written as P by A plus PE square by P square plus PE into Z minus MD plus ML by Z. Okay, this is the formula. Z at section modulus at bottom you can write B. Similarly, if you talk about the stress at top, you can write that P by A, the form PE by, minus PE by ZB, ZT plus MD plus ML upon ZT. Sir, we also have load balancing concept. Suppose if you consider load balancing concept means whatever the moment which is occurred due to a point load, suppose you will take WL by 4 moment due to point load, this will be balanced by the pre-stressing force, sir. What is the pre-stressing force? It will act in this way and this will act in this way. So both should be balanced. That you can write it as load into eccentricity, where P is the pre-stressing force. Here what will be the eccentricity? E is equal to WL by 4P. I hope these formulas are helpful for you. My dear students, the silent features of IMS GATE Academy are we provide the 800 plus hours of GATE coaching, offline, online and self-recorded sessions. My dear students, we at IMS GATE Academy provide you the subject-wise material, and also we provide chapter-wise test, advanced level test, multiple subject tests, and also we will be providing the all India mock tests which are similar to the GATE environment. And my dear students, we are offering one-to-one mentorship, and we are also offering the doubt solving sessions. My dear students, we are the only institute in Andhra Pradesh who are providing the offline gate coaching at Vijayawada near Ben Circle opposite to Enadu. So my dear students, if you are preparing for GATE 2025, then definitely you have to visit our IMS GATE Academy YouTube channel. What should be the roadmap for GATE 25? What are the opportunities through GATE exam? And my dear students, after securing a marks in the GATE exam, what you have to apply, what are the opportunities, and post-gate guidance also will be given in the YouTube channel. So my dear students who are interested, please join the link and join the Telegram group for all the further updates. I hope this session will be helping you to quickly revise the formulas on RCC. My dear students, stay positive, be healthy, and all the best for GATE 24 exam who are appearing for the GATE 2024 Civil Engineering paper. All the best, my dear students. Thank you.